Hello children, today we are going to revise the chapter Sound and some natural phenomena. First I am going to take up sound. Children, you know what is sound? Sound is a type of energy, kind of energy, and it is produced by the vibration. Some important terms related with this sound I am going to tell you. First is amplitude. What is amplitude? The maximum distance by which the bob moves away from the mean position is called the amplitude of the oscillation, and amplitude is related with the loudness. If amplitude is high, the sound is loud. Now come to the time period. The time taken by the pendulum for one oscillation is called the time period of the pendulum. The next term is frequency. What is frequency? The number of oscillation per second is called the frequency of oscillation, and frequency is related with the pitch of the sound, and it is measured in hertz. Okay. Now what is loudness? The loudness of the sound produced by a vibrating object depend on the amplitude of vibration. Already I told you, and the pitch depend on the frequency of the object. Now we are coming to the quality of sound. What is quality of the sound? The quality of a sound is determined by the frequencies present in it and their relative loudness. Next thing, how do we hear sound? How do we hear sound? You know, we hear the sound by our ears are sensory organs that help us to hear sound. The parts of ear are outer ear, middle ear and inner ear. How we hear the sound? A vibrating object causes air molecules to vibrate. When these vibrations reach our ear, they are collected by the pinna and funneled into the ear tube. These then strike the eardrum, which starts vibrating with the same frequency. This causes the delicate bone of the middle ear to vibrate. These bones amplify the vibrations and transmit them to the inner ear. The vibration stimulates tiny hair cells in the hearing organ, which send a signal to the auditory nerves of our nervous system. The auditory nerve takes the signal to the brain and we can hear the sound. Next is audible and inaudible sound. Audible and inaudible sound. Children, what is the range? Audible and inaudible sounds. Okay. So what is the range of frequencies? I am going to tell you. Our ears can only hear sounds with frequencies between about 20 Hertz and 20,000 Hertz. This is called audible frequency range. Low frequency sound which we cannot hear are called infrasonics, and above than to 20,000 Hertz produced sound that also we cannot hear, and we call those sounds ultrasonics. Okay. Next thing, sound requires medium, solid, liquid and gases. Okay. So sound requires a medium to travel, which can be solid, liquid or gas. And children, the speed of sound is maximum in solids, lesser in liquids and minimum in gases. Next our topic is echo. What is echo? Children, sound is reflected from a surface in the same way as a ball bounces from a wall. We call this echo. And next is sound absorption. Like bouncing back is called echo, but some surfaces like hard surfaces bounces back the sound waves, but the soft surfaces are better absorber of sound and hard surfaces are better reflectors of sound. Okay. Now children, I am going to tell you about the sound produced by human. How do we produce sound? Okay, we produce sound in the larynx of our throat. The larynx has two vocal cords which are folds of tissue. Fold of tissue with a slit like opening between them. When we speak, air passes through the opening and the vocal cords vibrate to produce. Children, like women and children, they have shorter vocal cord. Okay, like women have shorter vocal cord than men, and children, they have very short vocal cords. That is why the frequencies of sound produced by women and children is of higher frequencies than sound produced by men. Now we are coming to the musical sound. What is musical sound? Regular vibrations produce musical sound, and children, irregular vibrations, they produce noise. Musical instruments, they are of three types. First is stringed instrument, second is wind instrument, third is percussion instrument. Stringed instrument, the examples are sitar, guitar. They use vibration in metal wire to produce sound. Okay, and the frequency of sound is varied by varying the length of the vibrating wires. Second is wind instruments. Flute, shennai are wind instruments. They use vibrations in air column to produce sound. Holes in flute are example are opened or closed in order to change the length of the vibrating air columns. Next is percussion. Drum, tabla, mridangam are percussion instruments. They have a stretched skin whose vibration produce sound. Loudness is increased by striking the skin harder. Now we are coming to the noise. As I told you, irregular vibrations, they produce noise. An unpleasant, disturbing sound, especially one that is loud, is called noise, and it is produced by irregular vibration. We measure the loudness of sound like the unit measured to loudness of sound is called decibel. We write it like this: D and capital small d and capital D. Decibel. Acha, now that what are the major sources of sound pollution? Road traffic, air and rail traffic, neighborhood and domestic noise, noise from industries. So these are the sources of noise pollution. Next is we are going to discuss noise pollution is having some harmful effects, like it causes nervous breakdown. Sometimes people, like noise can cause permanent hearing loss. Okay, and more than 70 decibel can cause gradual hearing loss. High noise level can also lead to nervous tension and increase of blood pressure. We can control this noise pollution by planning land use to reduce noise. For example, making tree-lined buffer zone between residential colonies and roads with traffic. Second, reducing noise emission by developing low noise products, for example, better silencers for automobiles. So children, we have discussed this chapter. Now we are going to discuss the other chapter, that is what? Some natural phenomena. Children, there are two types of charged particles, positive and negative. Okay, all you must be knowing. Benjamin Franklin, a scientist of the 18th century, gave a specific name to these charges. The charges on the two types, these charges, positive and negative. Now, how different? There are different ways of charging a body. If we want to charge the body, we can charge by three ways: charging by conduction, charging by induction, and charging by friction. So these are the three ways we can charge the body. In friction, like in friction, when two objects are rubbed together, there is friction between them. Therefore, the method of charging an object by rubbing it against each other is called charging by friction. Charging by conduction, an object can also, like this happen because some charge from the when we bring two bodies very close or we touch the body, what will happen? Some charge from the charged body gets transferred to the uncharged body till both are equally charged. This is called charging by conduction. Charging by induction, a body can also be charged by bringing a charged body near it, but not touching it, okay, from distance. This is called charging by induction. In this case, the body being charged acquires an opposite charge to that of the body charging it. Now next thing, how we can find out the body is charged or not by a device is called electroscope. Electroscope. So electroscope is a device to detect, measure and find out the nature of charges. Okay. Next is how the body which allow the charges to pass through them, we call them conductors, and the body which cannot allow the flow of charges are called insulators. Okay, what is earthing? Earthing, children, sometimes extra charges, transferring of charges from a charged object to the earth is known as earthing. Okay, now we are going to discuss atmospheric electricity. Atmospheric electricity. Okay. First time, Benjamin Franklin, he proved that clouds build up charges during a storm. How this electric origin of atmospheric electricity take place? During a thunderstorm, clouds gather charge. It is not known exactly why this is happening. Some experiments have suggested that charges develop in water droplets present in the clouds. It is seen that lighter droplets acquire positive charge, and being lighter, they move to the upper region of the cloud. Bigger droplets acquire negative charge, and being heavier, they move to the lower region of the cloud. Electric discharge and lightning. Children, when the quantity of charge is large and the distance is small, in such a situation, very heavy charge passes through the air, like more positive are there and negative are there. What happened? Such time, what happened in such situation? Very heavy charge passes through the air. In a very short time, normally this is accompanied by heat and light, and this phenomena is called electric discharge. I am going to explain you how it happens in the cloud. When two clouds with unlike charges come near to each other, there can be very heavy discharge between them. Like these charges, they come close to each other, and what takes place? Electric discharge, and because of electric discharge, lightning takes place. A very heavy discharge between them, huge amount of energy is released in the form of heat and light, and we call this lightning, and we hear the sound, that is what? Thunder. Clouds can charge tall buildings and trees by induction. The buildings and trees thus acquire the opposite charge, like this is tree or any building, this acquire opposite charges due to what? Induction, and this electric discharge can take place between the building and clouds, between trees and clouds. Okay. So lightning is a very heavy flow of charges between clouds or between clouds and earth. While lightning it is very dangerous, it is also useful to us in some ways, like during the lightning what takes place, children? Formation of ozone takes place, that is good for our earth. It protects us from UV rays. And second, formation of oxides of nitrogen takes place. Okay. Next is the lightning conductor. This lightning takes place and it is very hazardous. It can destroy the tall buildings and all. That is why lightning conductor is fixed on tall buildings. Okay, a lightning conductor consists of a metal rod ending in spikes at the top. The lower end of the rod is attached to a copper plate buried deep in the earth. If lightning does strike the building, it flows harmlessly to the earth through the metal rod and no damage is done to the building. This way we can save the building by lightning conductors. Okay, now next topic is earthquake. This is also a natural phenomenon. What is earthquake? The shaking of the ground caused by sudden movement in earth crust is called an earthquake. Children, the waves generated by earthquake are called seismic wave. These are recorded by an instrument called seismograph or seismometer. The characteristics of an earthquake wave can be recorded on the screen of a seismograph and is called seismogram. Okay, so this is very important. I am repeating again. These waves are recorded by an instrument and the name of the instrument is seismograph or seismometer. The characteristics of an earthquake waves can be recorded on the screen of a seismograph and is called a seismogram. The science that deals with the seismic wave is called seismology and earthquake scientists are called seismologists. Children, now I am going to tell you about the Richter scale. Richter scale developed by Charles F. Richter, and it is used to measure the magnitude or intensity of earthquake. Okay. The number indicating the magnitude of intensity on Richter scale ranges between 0 to 9. The Richter scale is not a linear scale like the scale you use. On this scale, the vibration of an earthquake with a magnitude of 2 are 10 times greater in amplitude than those of an earthquake with the magnitude of 1. So between 1 and 2, whatever the intensity, that increase 10 times between 2 and 3. Okay. Now what are the main causes of earthquake? The Earth's lithosphere is divided into about 20 parts called tectonic plates. These plates float over the hot magma below and therefore in relative motion. So the Earth's lithosphere is divided, I told you, the Earth's lithosphere is divided into 20 parts called tectonic plates. These plates float over the hot magma below and therefore in relative motion to each other. When these plates collide and the rock at the joint is sufficiently slippery, the plates slide over each other little by little. However, sometimes what happens, children? The rocks at the joints can interlock and get stuck, resisting pressure from within. For years, the forces pushing the plates build up until the strain can rip the two plates apart. The rock crack and shift, sending shock waves of energy in all directions. When these waves reach the surface, they are felt as earthquake. And children, the important terms, the point from which the earthquake waves originate is called the seismic focus. It lies within the crust of the earth. The point on the earth's surface vertically above the focus is called the epicenter of the earthquake. Okay? And children, the boundaries of the tectonic plates are the zones where earthquakes are most likely to occur. These are known as seismic zone or fault zones. Seismic zones or fault zones. Okay. Now volcanic activity also, children. After this volcanic activity, I am going to tell you about volcanic activity. Volcanic activity is another main cause of earthquake. Almost each volcanic eruption is followed by earthquake, and many of the severe earthquake can cause volcanic eruptions. Now, effects of earthquake. What happened because of earthquake? Deformed ground surface takes the earthquake tremors, and the resultant vibration result in the deformation of the ground surface. Damage to human-made structure like many building, road, rail, factories, dams, bridges get severely damaged. Damage to the town and cities also take place. Loss of human and animal life takes place. Devastating fires take place, and landslides takes place. We can protect against earthquake. In highly seismic areas, use of timber is better than bricks and concrete. Okay, roofs should be made as light as possible. Houses made of timber are very popular in Japan, which is highly prone to earthquake. Next is buildings should be made quake safe by constructing them according to quake proof norms. Firefighting equipment should be installed and kept in working order. Okay, children? Now next is the following are some steps we should take if we are caught in an earthquake. Do not stay near the window, bookcases, mirrors, hanging pots, fans during or immediately after an earthquake. Leave your home or school building and move to open areas. If outdoor doors, keep away from high-rise buildings, trees, signboard poles and electric poles and electric wires. Do not sit inside a car or a bus. Help others according to their needs. So that's all, children. All the best.